What was it?
It was a question like negative y minus 6 and y to the power negative 6 over y.
Okay, so y to negative 6 divided by y. This is an exponential rule. I will have to copy the base and subtract the exponents only and always in this order. From the exponent of the numerator, I subtract the exponent of the denominator. So this is y to negative 7. Now I have a rule that we didn't get to yet. So this is at the end of this chapter. So we have not discussed this rule. Now, since I wrote it, allow me to discuss the rule, and then I'll come back and discuss it again. So this is a notation that implies a fraction. 1 over. So every time I see a quantity raised to a negative exponent, it's basically a fraction. It's not a negative number. It could be a negative number at the end after I simplify it. Bless you. But right now, it's not a negative number. So when I see a negative exponent, I am not to assume that the final answer will be a negative number, ever. I have to wait and see. All I can say at this point is that y to negative 7 is 1 over y to the positive exponent. And later on, basically in chapter 10, in 012, you will learn that negative exponents are not allowed in the final answer. So this expression, if you leave it as is, it's not fully simplified. You have to change it like this. So the power rule, it's not a power rule, it's the negative exponent rule that we will get to at the end of this chapter today is a raised to negative exponent is 1 over a raised to the positive exponent. Okay? So I'm back now to is there anything else?
Yeah, because when I was reviewing some of the questions, some of these is not. Some of them give me straight answers. Like,
see, y to negative 27 is 1 over y to positive 27. It's not the same. If it's at the top or in the denominator, it cannot be the same. So x to negative 9 is 1 over x to the 9th power, according to this rule. So we have to correct that. Okay? So you're wonderful. You're way ahead of me. That's awesome, because you know what to expect. And I'm sure, Chris, you probably finished the whole thing, right?
Yeah.
Yeah, chapter 7. Are you in chapter 7 already?
I think so, yeah.
Okay. Do you want to teach? I can sit down and... Okay. Very good. So we're moving on to 5.4. Anything else between 5.1 and 5.4? Okay. Special products. This is a very important topic. And if we understand it and commit it to memory now, you'll have a very easy life in math. If we continue to foil what I'm going to show you today, you're going to fall behind. You're always going to ask yourself, how did she get that? Okay? So please trust me on this and try to understand what I'm doing in this section and commit it to memory. And I think I showed last time what I give to all my students, other than this class. And I will give it to you because I showed it to you last time. I don't want to waste your time right now. I'll find it. Okay, I will give it to you at the end of when we start reviewing chapter 5. It's like a little joke that I have with my students, kind of an agreement that we sign and we cannot breach it. So maybe that will help you remembering these special products. Here's the first one. As you notice, this is not an exponential rule because this is a binomial. Is a plus b a binomial?
Yeah, it is.
Good. It has two terms. The same thing with this. We cannot apply the exponential rules here. What we can do is write what it equals to, which is a plus b times a plus b, and then use FOIL like we did last time. A times a squared, a times b, ab, b times ab still, and b times b squared. We learned last time how to combine like terms. Is there anything I can combine here? Do we have like terms here?
A and B.
Right, so this is a square, so this is 1 apple plus 1 apple. How much is that?
2.
Thank you. This is very dry, right? So I'm showing you an a plus b, and what does this really mean? Well, here's what it means, because you're not going to have a as the first term, and you're not going to have b as the second term. You're not. This is the general form of the special product, which is, as you see, what is this? And let's write it. And this from this moment on, you have to commit this to your memory. What did we say was this? What do we get when we square binomial? What is exactly? Say it louder with me. Yes. So this has to be embedded in your system right now, forever. Anytime you square binomial, the answer must be a trinomial.
Does that apply to other types?
Any binomial squared is a trinomial.
So like, what is like a trinomial squared something in
Yeah.
particular? Or?
No. Very good question.
Okay.
When you square a trinomial, then initially you will get 9 terms,
Right.
and then it will collapse
Okay.
into 6, because 2 pairs will add up. But we don't go that far.
Gotcha.
But when we talk about binomial, and we do talk about binomials a lot, when we square binomial, we get 3 terms.
Okay.
What if I cube a binomial? What do you think we're going to get?
I guess 4 terms.
Exactly. 1 term more than the power.
Yeah.
So when I square binomial, I get a trinomial. When I raise it to the 3rd power, I will get 4 terms, always 1 more than the power. But we don't go to trinomials. We don't really square trinomials, not because we don't want to. We don't create rules about, we haven't created rules about squaring a trinomial. We are interested in binomials. When we get to trinomials, we don't really think in terms of, okay, let's come up with a rule for a trinomial. We didn't do that yet. Okay? So a binomial squared is a trinomial. That's one thing that I want you to commit to memory. The second thing that I want you to commit to memory is, don't erase it like that, this is not what I'm really interested in. What I'm interested in is remembering any first term, ft, first term, plus any second term, not just simple a and simple b, because it can be anything. And you are not going to get, as I said, the a and the b squared. Now I have to understand the pattern. This is extremely important to understand what happens here. Look, the first term squared plus 2 times the first times the second plus the second term squared. This is what I have to commit to memory. Not a plus b, everything squared is a. No, because you're going to get a and b. So what is the pattern? Can anyone dictate the pattern? ft squared plus
FT plus ST. Oh, 2.
2 times,
FT and ST.
yes, ft times a st, very good, plus,
ST squared.
that's it. This is what I want you to commit to memory. First term squared plus 2 times the first times the second plus the second term squared. And you should have it in the next week or so. You should be able to square everything and anything you can think of. Now you can say, I don't want to memorize this because I can FOIL. Okay, but then you're going to have terrible difficulties in chapter 6. Yes, you can FOIL. Nobody will prevent you from foiling. You'll get full credit for foiling. But then in chapter 6, you're going to say, how did you get that? And you will never pass that difficulty.
So this was a distribution, right? Yeah, it was. You distributed it. FT squared plus, okay.
I did not distribute. I did not use FOIL here. I learned the pattern, and I went directly from here. I distributed it. If I'm foiling it once, I'm not going to do it again. Can you? Yes. Are you allowed to? Yes. Should you? Waste of time, and you're not going to learn. Trust me. So let me give you an example here, what I mean. So if I have, let's say, 2x squared plus 3y, everything squared, I expect you to give me the whole thing without foiling. If you want to have a breeze in chapter 6, if you want to hit a wall all the time in chapter 6, then you'll still take it on the side and foil it. This is so useful that we are using it in the next course, and O12, and the next one, in 137, and so on and so forth, because we are going to learn how to complete the square in the next course. If we don't understand this, we're going to say, how did you get that? Why are you dividing by 2? Why are you multiplying by this? So please, the first term squared.
Where's 4?
Awesome. Plus 2. 2 times 2 times 3. 2 times 2 times 3. 2 times 2.
12.
Yes, times x squared times y. 12x squared y plus second term squared. Say it again. That's it. How do we do this? By understanding the pattern, by remembering the pattern and what happens here. Foiling is allowed. You will get full credit, but you're not going to make progress in the next course and the next chapter. So please bear with me. So what do you think about the other one with minus? Please make the effort on this now. What do you think I should write for this? Give it a
rule or for the answer?
for the rule and the answer.
A squared minus AB, or 2AB, minus B squared, or plus B squared, or 2 negative.
That's it. That's it. Once we understand the pattern, you will see it all the time. So now let me give an example. 3y squared minus 4, everything squared. I need the pattern. Very good. 9y to the 4th. Because it's minus, I have to put minus. 2 times 3 times 4. Very good. 24 what? Very good. Plus. That's it. Why is this so important? If you listen to me, you're going to be happy in the next chapter. It's not going to be difficult. Because in chapter 6, we're going to go backwards. We are going to be given this. And we will be asked to factor it into this. That's the point I'm making. That's why I have the case in front of me to make for you and hopefully convince you that the pattern is so important, because we're going to be given this. How will I determine this?
I have a question.
Sure.
So the power to the exponent to the power 2, do you multiply that to get the 24? 3 times 4 times 2?
Exactly.
Okay.
Not the exponent, but it's this number.
Okay.
Because we will have 2 terms alike, right? So that's why you have a 2. So 2 times 3 is 6. 6 times 4 is 24.
Okay.
Better?
Yeah.
Okay. So let's look at examples now from the book, or you can make them up. Okay, on page 341. These are not the only 2 special products. I need another one, but I want to practice this. There's a third one. So let's say problem 18 on 341. 5a plus 2, everything squared. 5a plus 2, everything squared. Okay, on the handout that I gave you last time, these are the 2 special products that we just talked about. Okay, and we're going to get to negative exponents and everything else in a minute, and division. Okay, so on handout for chapter 5, on the back, these are the 2 special products we just talked about. Okay, so can anyone follow the pattern and not foil and give us how many terms, by the way?
3.
Exactly 3. A binomial squared is 3 terms. Yes, I'm going to ask you that question a lot. So I'm ready. First term squared.
25a to the power 4 squared.
Very good. Plus 2 times the first times the second. Very good. Awesome. Plus, that's it. Once you see it, but you have to make a little effort to see it, then it will stay with you. Okay, 6x minus 2, number 20. 6x minus 2, everything squared. When I see a minus in the middle, I know the trinomial will have what in the middle? Awesome. Good. So please follow the pattern.
6x squared.
Yes? I want the direct answer. You can write it on the side. That is not wrong. To write this on the side and see what it is, I'm fine with. Remember, this is an exponential rule. 2 factors squared. So what do I have?
36x squared minus 24x
2 times 2 times 6. Very good. Plus,
plus 4.
that's it. Very few put the effort to understand the pattern and not have to. Yes. Yes, you had a question?
I'm just wondering about say 2 times 2 times 6, which I get, but up in where was 5a 5a
2 times 5 is 10. 10 times 2 is 20.
Oh, okay. I was under the impression you're squaring that. That's why.
The middle one?
Yeah, the middle part. I was under the impression it was 2 outside exponents.
2
Oh,
times the first times the second. 2 multiplied by the first multiplied by the second.
I forgot.
And I can rearrange them the way I like so that I can make the product as easy as I can.
Okay.
So that's why I say 2 times 2 times 5. It doesn't matter. Or 2 times 5 times 2.
Okay.
The answer will still be the same. Better? Okay. Good. So let's look at 46. 5b minus 4x, everything squared. Please work on this. I'm going to copy a couple more. 56 twice 3b plus 7, everything squared. And then 79, I want to find the area of this square. Can anyone give us the answer for 46? Remember what you should say today when you drive home? Just say this. First term plus the second term, everything squared, is the first term, plus the 2 times the first times the second, plus the second term squared. And you will not forget it. Okay? So, ready?
Is that 5b?
Yes.
Is it 25b squared plus
Careful, if this is minus.
Minus 40bx
Very good.
minus 16.
That's never the case. That's never the case. The first term is always positive, the last term is always positive, only the middle one could change, either positive or negative.
So then plus 16x to the 4. Oh, squared, because there's no. I just didn't see that.
Very good. Is that clear? So the middle, I just realized that I forgot my, no I didn't. What did I have? Never mind. Okay, this one. What do I have to do first?
2 times 3 gives you 6.
You deal with the
That
exponent
is
first.
6.
Of course. Of course, I cannot multiply before. Of course, the power, the exponent is first. I cannot, I'm not allowed to distribute.
I thought it's parentheses for exponents.
Right. Parentheses before exponents. But the parenthesis has an exponent.
Yeah, I guess you're right. I guess the 2 is the multiplication.
Exactly.
Yeah, no,
This is the weakest link of the two.
Okay.
I have to apply this first.
Okay.
Unless you say, let me square it. Make it 4. Plug it in. But I don't recommend it. It's not a good thing to do. You understand what I'm saying? Once you square it, you can put it in because now everything is squared. But don't do that.
Okay.
Okay? So, I have to perform the operations in parentheses. I can't because I have no idea how to combine 3b plus 7, not like terms. So then, therefore, I have to square this, and at the very end, this was a trap. Okay, so 2 multiplied by
9b squared plus 14.
I didn't hear.
14. Or, excuse me, 7 times 7. Whatever that is.
2 times 3 is 6.
Oh, shoot.
6 times 7 is 42. Be very good. Plus, that's it. Now, I can distribute 2. So 18b squared plus 84b plus 98. This is it. So please pay attention. We have to square first. Okay, how do I determine the area of the square? Can anyone tell us what to write first?
Length times width. The area of a square.
The area of a square is the side squared.
Yeah, 2x plus 1. Square.
Good. Ready? How many terms will you give?
3.
Very good. Awesome. Ready?
4x squared.
Awesome.
8. 8x. No. 2 times 2 is 4.
Very good. Plus
2.
1.
1 squared is 1. Very good.
Confused.
Say it again.
I'm confused.
First term squared, 4x squared, plus 2 times the first times the second, 4x, plus the second term squared, 1.
Okay.
That's why it needs time. It may not happen in 5 minutes or 10 minutes or today. That's why you have to remember it. You have to work on it.
So for the middle part, when you say 2 times the first term times the second term, is the 2 actually representative of the exponent? So if I were to do a cubed, would I replace that with a 3, or does this not work for that?
No. Remember, it's a very good question. So if you want to raise a binomial to the third power,
Right. Different rules apply? Yeah, okay, that's what I figured.
we do not teach that.
Okay.
There is no need. However, I can show you we have methods.
Okay.
We have 2 methods. One is the Pascal's triangle. You can look it up. And the other one is combinatorics, which is a little bit more involving. But for a plus b to the third power, the answer will be a cubed plus 3a squared b plus 3ab squared and plus b to the third. Okay? We do not study this formula in this class. And we do not study Pascal's triangle in this class. And I can show you how to determine a plus b to any power you want. If you want 15 here, you'll get 16 terms. And I can show you how. But this is not part of this course. Okay? So, when we square, one more time, this becomes the first term. This becomes the second term, correct? That's why I said, please do not be fooled by A and B. A stands for anything as the first term, and B stands for anything as the second term. As you see, I gave you several examples. So that's the way we have to see these 2 terms. Remember when I said about a function, if you have something like, oh yeah, this is a function, but what does it tell me? This is what this function tells me. So if I want to evaluate this function, what do I see? F of whatever equals whatever plus 1 over 2 times whatever plus 1. The same thing here. So when you look at the first quantity, if you don't see A, I'll say, oh, I don't see A, I can't use it. Yes, that's why I'm trying to make the point that this can be anything. This can be anything. As long as we understand the pattern, we'll not have any difficulties later. Okay. We're done with this. Now we have one more special product to look at. So let's take a look at the following. A plus B times A minus B. For now, let's look at it as A and B. But it's really not A and B, because you're not going to get this again, right? So this is the general formula. A times A squared. A times negative B, negative AB, plus B times A, or AB. And then minus B squared. What I did was, I used FOIL, right?
Yeah.
Good. So now look at these 4 terms and tell me what you see. Yes, because they're opposite signs. So these two terms go away. They cancel. So what is the answer then? Very good. This formula has a name. It's called the difference of what do you think?
of B, A,
Difference of
A, and
squares. This formula is called the difference of squares. We're going to use it in chapter 6, and we're going to go from here, this way. So how do I remember this? I remember it as first term plus second term multiplied by, can anyone dictate?
First term minus second.
Exactly. And now how do we understand and remember the pattern? Can anyone dictate?
First term squared minus first term times second term. What's it? Second term squared.
That's it. That's it. So as long as these two are identical, but this one has plus and this one has minus or vice versa, the answer is always that.
I have a question.
Please.
So when I was solving the questions in M8, I came across this, but I distributed.
If you want to fall behind, continue distributing. I cannot force anyone. You didn't know that because
Yeah.
we just got to it.
Yeah.
Foiling is fine.
Mhm.
But in chapter 6, you're going to say, how did you get that?
Okay.
Okay? It's acceptable, it's full credit, distributing. But please stay away from that. Now, if I have here two terms that are not the same, I have to distribute. If I have here A plus B and here I have X minus Y, I have to distribute because they're not the same. I cannot use this difference of squares formula. But if I say that one of the three special products that we talked about today, stay away from distributing, from foiling. Please, if you can. Good. Examples now. 26 on page 342. So 10x plus 2 over 7 multiplied by 10x minus 2 over 7. Is a special product applicable here, I should ask? Is it applicable here? Are they the same? And the only difference is this sign. So are these two the same?
Yes.
Are these
Yeah.
two the same?
Yes.
It's just
Is the sign one positive and one negative?
Yes.
Can I use this?
Yes.
So please give me the answer. Yes, but I want the whole thing. What is 10x squared? You cannot just square x. You have to square 10x. So you cannot say 10x squared. You have to say
20x? No, 100x squared.
very good. Minus, it's the difference of squares. Minus. Yes. Awesome. Next one. 74. A over 2 plus 4y. A. It's not 9. It's A. A over 2 minus 4y. A whole new world opens up if you agree and you understand these three special products. You're making a leap forward, not a jump.
Well, I got a question. Can we go back to the other one real quick for a second? I don't understand how you got 100x. Because you said the rule's first term squared minus second term squared,
Yes.
right?
So the question is how we got this?
Right. So do you,
The exponential rules from last time, when I have a product to
Right.
square,
Right.
I have to square 10 and I get 100, and I have to square x and I get x squared.
Oh, okay. That's the thing that was confusing me. Okay, I understand.
And then when I square a fraction, I square the top and I square the bottom. Another exponential rule from last time.
So square everything.
Exactly.
Okay.
Because it's a product or a ratio. If I had 10 plus x, totally different story, 3 terms.
Right.
Better?
Uh-huh.
Perfect. So can anyone give us the answer for this?
Is it a squared
Perfect.
over 4
Perfect.
minus
Perfect.
16y squared?
Awesome. First of all, you learn something. Secondly, you're not wasting your time. You may even make a mistake by putting plus plus or minus minus and not canceling those 2 terms. You understand that when we multiply binomials that are identical and the only difference is the sign in between, the answer will be a difference of squares. And when we get to chapter 6, the difference of squares will factor into a product of a binomial and another binomial, one with a sum and one with a minus. And that's what I need for later. Okay, let's look at I want to make one up. X squared minus 4 and x squared plus 4. And then I would like you to make one up. Please make one up for me. Okay, please make one up for me.
3x squared plus 9. 3x squared minus 9.
Awesome. That's it. That's the idea. That's all I wanted. Good. So I need an answer here, please.
The x to the power 4
Awesome.
minus
Yes?
16.
That's it. Great. Great job. And the one Corey made up? Blame him, not me. Just kidding. Just kidding. Just kidding.
3 to the second power.
Which is?
6.
Please.
9
9.
x to the power 4
Very good.
minus 81.
That's it. How did we get this? By understanding first term squared minus the second term squared, whatever the first term and whatever the second term. Awesome. Moving on. Let's look at these negative exponents now. I'd like to go back to the handout to talk about these 3 situations, and then we'll practice. And then we have the last 2 sections will be only on division of polynomials. Okay? So I want to look at these situations again. So this is section 5.5. Negative exponents. Okay. So as we discussed, a to negative n is basically a fraction. 1 over a to the nth power. What happens if I have 1 divided by a to negative n? So here you see this was in the numerator. So this represents a fraction 1 over a to the nth power. But now I have the quantity with the negative exponent in the denominator. If it is in the denominator, you will go back up with a positive exponent. How does this happen? So here's the explanation why this happens. 1 divided by a to negative n is 1 over, how do I replace this?
Positive.
No. But it's 1 over, right? This gets replaced by 1 over a to the nth power. It's in the denominator. It has to be a fraction. And then I flip, right? Because I have 1 divided by a fraction, so that's how I get a to the nth power. Is that clear? Yes. So I was explaining how we get this, right? So 1 over a to negative n, 1 over a to negative n, I copy the 1, fraction line, I copy it, and I replace this by this, because that's what it equals to. Then I divide the numerator, which is 1 over 1, 1 over 1, and multiply it by a to the n over 1. And that's how I get a to the n. Because if you remember, when we divide fractions, we copy the fraction from the top and flip the fraction from the denominator. And here I have 1 over a to the n. It becomes a to the n over 1. So if I have a to negative n, any quantity raised to a negative exponent, I can write it as 1 over a to the n. If the quantity with a negative exponent is in the denominator, I can move it up with a positive exponent. So if it's at the top with negative exponent, we'll go to the bottom with positive. If it's at the bottom with negative, we'll go to the top with positive. Yes?
Is that an inverse? Because 1 over 1, point A and over 1. Is that an inverse of?
When you divide two fractions, you copy the fraction from the top and you flip the fraction from the bottom, like the division rule. Now, what do you think, once we talked about that, what do you think a to negative n over a to negative m be replaced by? What do you think? Because this is a summary of the first two. Where will this one go?
That will be 1 over.
Where will this one go? Where will this one go? So what will be the answer then? A raised to the m over a raised to the n. This will go here with the positive exponent, and this will go here with the positive exponent. And one more, a divided by b. This is a fraction now, raised to negative n. When it's not a fraction, I have 1 over. But this one is slightly more difficult, but we'll figure it out in a minute. It has a fraction raised to a negative exponent. So I will be moving this fraction to the bottom with positive exponent, or
Inversing it.
so b over a with positive exponent. So these are new rules that we're adding here. Okay, here's a tricky one. 3 to negative 2 plus 3 to negative 1. And I have